In this video, we're going to discuss concavity. So previously we discussed one kind of feature of a graph, and that was increasing and decreasing. All right, now we're going to look at another kind of feature of a graph. All right, so as motivation, one of the simpler shapes that can happen, well, the simplest shape that can happen when you're graphing something is just a line. The kind of the next simplest shape that can happen, because it's the next level up from a linear equation, is a quadratic, and their graphs are parabolas. All right, so what are some possible parabolas? Well, I can have just like the traditional parabola. I can have this wide parabola, really narrow parabola, but also the parabolas can go upside down. They can be wide and upside down and thin and upside down. I have all these different shapes. But in general, a parabola is kind of curve that kind of swoops down and goes back up, or swoops up and comes back down. All right, those are the parabola shapes, and we're going to talk about when does our graph kind of look like a parabola. As soon as I start having more turns, it's not a parabola anymore, but you can kind of see there's like a parabola hidden in these different parts of the graph. All right, so this is kind of interesting to us. When does our graph kind of look like a parabola? All right, we want to say that a part of a graph has a certain curvature, so it kind of looks like a parabola this way or that way. We're talking about its concavity. All right, so concavity is the new kind of definition, and that's what we're going to be kind of discussing in this video. All right, so what does concavity mean? There's two different types, just like increasing and decreasing. You can be concave up, and up rhymes like cup. So if you're concave up like a cup, right, if you draw a cup, then that is positive concavity. Right, you're concave up. If you're concave down, that should be concave. All right, concave down like a frown, just means you're going the opposite direction. All right, so these are our two types of concavity. All right, we have increasing and decreasing on one side. All right, and then another thing, now we have concave up and concave down. And we have these nice little rhyming schemes to help us remember what they actually look like, because it's not as obvious as increasing and decreasing. All right, so given this graph, I determine when the graph is concave up. All right, so let's think about what this graph looks like in terms of concavity. All right, at the start, I can kind of see there's this upside down parabola here, and the left-hand side of that parabola kind of goes down forever. So I'm starting frowning this whole time, but you can see on the right here, I have this upward parabola, I have this cup, and that's going to keep going forever. And for right now, we're not going to know exactly where these kind of mesh together, but we'll just kind of put it in the middle like that. Right? So if you just look at the blue part, if you hid the green part, it looks just like an upside down parabola. If you just hid the blue part, the green part looks just like an upward parabola. So when is the graph concave up? It's the green part, which is 0 to infinity. Again, this value might not be exactly right, but it's close enough, kind of in the middle of these two concavities. And we can see that if we hide the blue part, that green part just looks like an upwards parabola. All right, so for this graph, we're going to determine where it's concave up again. Again, I always like to start with the local extrema, because I know if this is like an upside down parabola here and here. So these are going to be concave down, and these are like normal parabolas. All right, concave up. And this parabola is just going to continue forever to the left. This one continues forever to the right. And the other ones kind of meet in the middle. So if I just kind of meet these in the middle, again, it's not going to be exact for right now. We're just kind of looking at this graph, but if I look at those kind of red sections without the green sections, it looks like kind of two upside down parabolas. If I had the red sections and just look at the green sections, they look like two normal upwards parabolas. Right. So these are my concavity. Concave up, again, is like a cup. So I'm looking at the green parts. Now it's from 2 to 4. And from 6 to infinity. All right, so those are the places where it's concave up. Those concave down, you would say the opposite intervals. All right, so here's one for you to try on your own. All right, when is this graph concave up? And I'll show you the answer in 3, 2, 1. And the answer I got was negative infinity to negative 4. So again, hopefully you're recognizing that these like local extrema help you start out. So this is definitely concave up. This is definitely concave down. They kind of meet in the middle between them. All right, but they're going to go like that way forever on the outsides. All right, just like with increasing and decreasing, our goal is just to get to a point we can do this with an expression rather than with a graph. All right, so here's the important things to remember from this video. If you're concave up, you're like a cup. If you're concave down, you're like a frown. So that's really the most important thing from this video, and then we'll talk about how to use calculus to find these things in a future video.